Okay, picture this. You're a developer, you're in the zone, you go to install a command line tool you use every single day, something you trust completely. But what you don't know is that this time, hidden deep inside, there's a trap. A trap designed to steal your most valuable secrets before you even have a clue that anything is wrong. So today, we're gonna break down exactly how this happened.
You know, this isn't just some hypothetical question. It's exactly what happened in a really sophisticated supply chain attack that turned a trusted security tool into a weapon against its own users. In this explainer, we're going to deconstruct how a tool designed to protect secrets was, for a short time, turned into a tool for stealing them.
And the target here wasn't some obscure random library. Nope, it was the command line interface for Bitwarden, a name that developers and security pros absolutely rely on for managing their secrets. I mean, the very tool meant to be your digital vault was compromised to become a key thief. It's just wild.
So, let's get into the specifics. The attack was surgical. The rogue package was version 2026.4.0, and the malicious payload was cleverly tucked away in a file named b1.js. But here's the crucial part. The entry point wasn't a bug in Bitwarden's own code. Instead, the attackers compromised a GitHub action inside their CI/CD pipeline. You know, the automated system that builds and publishes the software to inject their malicious code.
So you're probably asking, how on earth did they get their code to run? This is the real core of the heist. It's so clever. They didn't need to mess with the main program at all. Instead, they exploited a seemingly harmless feature of the package manager itself, something called a preinstall hook.
So what in the world is a preinstall hook? Well, think of it like a secret instruction written on the inside of an envelope. Before you even get to open the main letter, which is the software you actually want, this hidden little script runs automatically. It's a feature that's supposed to be for legitimate setup tasks, but in this case, it was brilliantly twisted into a Trojan horse.
And this sequence right here shows you just how slick the attack was. It all starts with a command developers run 100 times a day, npm install. But before Bitwarden's code even begins to install, that hidden pre-install script executes silently in the background. And that is the moment of the heist. Credentials and secrets are scraped from the system and sent off to the attacker. Only then does the legitimate installation finish. And from the developer's side, everything looks perfectly normal.
Now, what makes this attack so incredibly alarming is that it bypassed a system specifically designed to prevent this exact thing. NPM's trusted publishing is meant to create this secure, unbreakable link between a code repository and the package registry. And yet, as security researcher Adnan Khan pointed out, this seems to be the first time a package using that very mechanism was compromised. The attackers didn't just find a vulnerability, they broke a fundamental chain of trust.
All right, so we've seen how the attack worked. Now let's talk about what the attackers were actually after. And let me tell you, the payload was not subtle. It was a digital smash and grab of epic proportions.
The malware's purpose was brutally simple: steal every single secret it could possibly find. It was engineered to be a digital vacuum cleaner, just sucking up the keys to a developer's entire professional kingdom from the very moment it ran.
And just look at the sheer breadth of what it targeted. This is insane. It wasn't just after one type of key, it was hunting for everything. GitHub tokens to get into your private code, SSH keys to access servers, .env files that are just filled with application secrets, and yeah, even your shell history to see what commands you've been running. It even went after credentials for cloud platforms and AI coding assistants. This was a full-scale digital intelligence operation.
And that right there brings us to the terrifying ripple effect, which is perfectly captured by this quote from Step Security. A single developer installing one malicious package can become patient zero. Their stolen tokens don't just compromise their machine, they can give an attacker persistent access to every CI/CD pipeline they can reach. In effect, they're handing over the keys to an entire organization's software factory.
Now, you need to understand that this attack on Bitwarden wasn't just some random isolated event. It was actually one part of a much larger, ongoing campaign that researchers have given a pretty cool name from the world of science fiction: Shai-Hulud.
This campaign, which is believed to be run by a group called Team PCP, is constantly evolving. These attackers are learning. They used to send stolen data only to private domains, but now they're using public GitHub repositories as a backup plan. And then there's this really strange detail. The malware is now designed to shut itself down if it detects a system with a Russian locale. This not only makes it harder to figure out who's behind it, but also kind of hints at some other motive behind the attacks.
And the danger of sending stolen data to public GitHub repos, it just can't be overstated.
As OS Security points out, this makes the risk so much worse. The stolen data isn't just with one attacker anymore. It's potentially visible to absolutely anyone searching on GitHub. The compromise basically becomes public domain.
So, with a threat this severe, how did the story end? Well, let's look at the response from Bitwarden and the huge lessons we can all take away from this very close call.
The speed here is just astounding. The malicious package went live at 5:57 p.m. Eastern Time. By 7:30 p.m., we're talking less than 90 minutes later, Bitwarden's team had already spotted the threat, revoked the compromised access, and deprecated the malicious version. It's a powerful reminder that in the world of supply chain attacks, the clock is always ticking, and a fast response is everything.
And here's the most important piece of news for all the users out there. Bitwarden's investigation confirmed that the attack was contained to the CLI's distribution path on NPM. No end-user vault data was ever accessed or put at risk, and none of their production systems were compromised. The core of their service stayed secure.
This entire incident, from the clever preinstall hook all the way to the rapid containment, it forces all of us to face a huge challenge in modern software, and it really leaves us with one critical question. In a world that's built on layers and layers of shared, open source code, how do we really verify trust in the tools we use every single day?